So our goal for first is to pick an image from this this folder. I'll share this link with you guys on the chat. If everyone gets the image, can everyone know if they got the link and if it's working?
Yes, for me.
Okay, thank you. Yeah, so let's start. First, because we took this photo on the this pedestrian street, so I'm going to just quickly make some adjustments to make it more orthographic. So first, ideally you have to do the grid and everything, but for the demonstration purposes, I'm just going to look this. Okay. I'm going to do it fast. Basically like this, and you want to change your the size of you want to change the canvas size like this. So if you look at this, canvas size is 512 by 512. So each of this the voxel will be very small size, but then when we assemble the images with the using TSNE, it will be very huge image. So here,
so quick question, what is the resolution of that PSD file? It doesn't matter?
what was that?
What's the resolution of the PSD file?
It doesn't matter. It doesn't
Okay.
matter. Yes.
Just size. Okay.
So you select this and the canvas size. Why is it not working for me? What's wrong? I need to check them. Sorry. So guys, so yeah, as you can see, like it becomes like this pretty small size. You have to think about how this will all assemble as a let's say one voxel into your TSNE image. So if you compare this image to this image, this component will be basically very small image within your grid. So yeah, that's how you should do it. Or if you want to automate this process, you can actually make this into just orthographic the file like this, and then save it as a PNG. Somewhere. For now, I'm just gonna put it in my desktop. And what we can do is that basically using the processing, we make these lines. So each one of the image can be cut into multiple images based on their resolution. So to do that, we're going to use processing. Has everyone installed their processing into their computer? Yes, okay. And one thing that we will have to activate is if you go to the tools, add tools, and the library, there is a toxic library by Karsten Schmidt, and PZCam, that's by the Jonathan Feinberg. These search for the PZCam. I'll put it in the chat. PZCam, and toxic group. So if you search for this two libraries and then install this, let me know. And also you need the Python mode for the processing 3. There is a 2 mode here. One is Java, one is a Python here. So make sure that is on. And for other than that, I think, yeah, we're all good. And I will go ahead and start with the this processing tutorial. So if I'm going too fast, let me know. I can slow down. So we will start with the setting up some values. So here, int is a short for the integer, and then we will set the resolution of the images for now. For now, we're going to put it as a 1024. That is the dimension of your image, as a square. And we're going to bring the p image, and we're going to set a string here, and we're going to import.
Maybe, sorry, Sang-Yan, can you enlarge the text a bit, because this text seems a bit too small?
Yes, yes. Bigger. Yes. Okay.
I'm going to okay with this size.
Maybe too big.
Yeah, maybe too big. It's going to bother you. All right. Yeah.
Yes.
Cool. Thanks.
And we're going for this particular one. We're going to use actually Java, not the Python. Sorry about the confusion. If telling you to install the Python, I only told you to install the Python because if we have a time at the end of the today, I'm going to do some tutorials on how to code in Python as well. So yeah, so just and we're just importing a few libraries that we need for the this code to work. So these are libraries, and now we're going to set some variables here. And at the end of the code writing, I will share my complete version so that if anyone hasn't followed up or had some problems, or somehow you guys are not here, then you can just use what I wrote for you. So these directions, this let's say the variables here is to indicate where the file is located, and then what's the current name, and then what's the name that's going to be output as, and then these PG graphics is just when it is to check if our code is working well when we run. And how Java works is that the void is a, let's say, more of a overall parenthesis for the entire code. And it is a good practice to actually, write the parentheses always as a open and close, because more time than you wanted, you would forget to close your parentheses. So here I'm defining the size of our image. But we can change this to 512 if we want 512 based on your need. And the convention for the Java is that you always put the semicolon after you're done with a certain function. For this setup, after setup, the reason why we don't put the semicolon is that it is just indicating that this is a one separate kind of operating system. It's like a some sort of a program in the window. So keep in mind that you always have to finish your sentence with the semicolon for Java. And this is a whatever directory. Directory of the incoming, okay? And out direction is the directory of outcome. Okay, so whenever we're doing the let's say image cutting, some files at a different location and this location. So for example, let's say I am using the desktop location, then desktop is actually a little weird. So I'm just going to move this image. Where's my image? Well, I'm just going to resave this in a different folder. So I'm just going to save this image in the dataset folder here. And what's the, let's save this first. Image to cut. Once we know where it is, we go chase that file. Here's the image, and you can basically copy this into here. The one thing that you have to make sure that is that in the processing, the slash and backslash is it could be problematic. So what I will do is that if you do Control F for the find function, you can use this find and replace thing. So don't use the backslash for your directory. You just use the slash, right? And then you see that all this is changed. And we're just going to use the same directory for now. But ideally, you want to create. Let's actually do that. And make sure you if you actually, let's say, copy and paste it right here, you don't have this like a backslash ending. So make sure to end with the backslash always. And we replace all that, and then now we indicated where the file is, and then we indicate where the file should be output after. Okay. And we can the name of the file as a namespace, and then let's say because this is a test, I'm just going to call it test, right? And I forgot this semicolon. See, it's easy to forget. PG, and this PG is this function create graphics is a function that's embedded in the processing that you can basically create the image of a certain dimension. So as you can see here, dim is this dim, right? So this is your desired the dimension for the graphics. So if you say 10,024, you would the outcome is that if you have a base image, it will cut 10,024, 10,024, 10,024 every time. But for our purposes, we need this to be a 512, right? And this is good now. Actually, this namespace is not actually the output. Sorry about the confusion. It's the name of the file that we have it here. So this should be image to cut or whatever the name that you have as a saved file. And this namespace out, it could be, you know, test. Okay, so that's the end of the how we set up the file structure for your so this part was the to indicate where the file structure of this, or the more like the directory of this file is, and the naming convention and everything. So we set up the basis for now, right? And here the draw function is more for the, let's say, performance of this code. Here, you can set up your background color, and yeah, this is you can change it to like blue or whatever you want. But then the convention here is that ideally you want to do this, right? But then if you just do 0, it will mean that for the RGB, so R equals 0 and the G equals 0 and the B equals 0. And these can be omitted by just doing 1 0 here if you're using the same color value for your background. That's just a convention of how it works. And here we are indicating we're now starting the performance here, so that this function is indication for the begin draw. The begin draw will initiate some sort of another screen here that's showing how your image is processed. So it's helpful for you to, let's say, check if it's working or not working, or it is outputting the outcome that you wanted to have. This is like a the reason why you have a spacing here is that this is basically the predefined function in the code. You usually don't want to have any sort of a spacing between your text, because spacing means some sort of a function in the computer language, very different from the human language. So that's one thing to note. And we're now going to call the string. The purpose of doing this, the parentheses here, is that we're going to make an array for this string. So here we define these as strings, but then from one big image, we're going to cut this into many different images. So ideally, we want to have a same naming convention for all these images that we cut. So what we're trying to design here is that the based on the namespace output, ideally we're going to get something like test 1/1 or test _1. This kind of the naming convention. So here we do and this is split is the function for you split the images into many different pieces. But then how, right? How is answered by this like a dimensional array I. I is integer. Integer is even like a not decimal point number. So 1, 2, 3, 4, 5, 6, 7. That's the integer. And the integer, by inputting this integer here, now we can, let's say, actually, we kind of skipped here. But if I complete the integer thing, so if this is a thing, we want to define the how many cuts that are going to happen here. 1, 2, 3, 4, 5. For computer, this is 0, 1, 2, 3, 4. And then these are the integers, I, and then this could be integer j, so mathematically, we're making an basically array. If you recall your algebra back in high school, this is 1, 2, 3, 4, 5, and then this, if let's say this is a function called, let's say, f, and then the f1 is 2, f0 is 1, f, let's say, like 4 is 1, 2, 3, 0, 1, 2, 3, 4, so that's going to be 5. If you put f5, it will put error, right? Because there is a no fifths array here, because it starts from the 0. Let me go back to the coding. Is there any questions so far? Are you guys following? If no one say anything, I'll keep going. Yeah, we want to define this the name of the things first. So here, this is like the file name. File names indicates the name of the file that we're going to have. And whenever you're doing array, you want to use the for loop. For loop means if you set up a certain, let's say, limit, you want to, let's say, loop it from the 0 to 10. So these numbers that you increase by your incremental value will end at this, the set limit. So first, because I is now empty value, you need to define this I as what value are we starting from. So yeah, so we're just defining how I is an unknown value to the computer, and we just defined it to be 0. If you don't predefine your value, your code will not run in Java. Python is a little bit different, but for Java convention, this is what you need. And now we're defining how I is increasing, let's say, by a certain number. So here, what I just did was that based on the files, the files lengths, I'm adding. So this plus plus, you could think that this is just, this is adding two into one, but then it's actually the sign for, or the convention for the Java to add one value into the existing value. So that's what it is. And here, now we're setting up the background color to whatever color you want. It can be, just your favorite color. Just type the code, the RGB code for your own color, and then you can use that as your thing. So just for your reference, 000 is white, and then the 250 to 250 is black, right? So if you want black, just leave it like that. And here, string. So what I just did was that in their name, this is the name of this file plus the file name will become our new file name. So our file name is image to cut, right? And then now it becomes image to cut 1 or 0 or 1, 2, 3, 4, 5, right? Expressing that as, since we defined this new variable, the file name, new file name, now we're redefining the string as array to indicate here. This is yeah, something like this. And now we are so all of this now is that to build the file structure or the naming structure for our cut files. And now we're loading the images. It's literally just a load image. It's an embedded function in the processing. And, now we're using if statement. If statement is if yes, and then otherwise. So based on the if statement, if this is the condition that you're describing in the statement here, then it will do certain performance. Otherwise, you can do, you can, let's say, make something happen on the otherwise. If this is not this, then it will do this, right? So it's a very similar to what we know as an if, but then you can assign, let's say, certain function to the yes or no condition. Here, yes. So I'm going to continue with this, and in the mathematical function, not equal. This is the not equal convention in the process in Java. So not equal, and null is an empty value. Here, and in the processing in the Java, it doesn't really matter that much where your tab is or where your inset is. You see this inset, but then it is a good practice to keep this aligned in the let's say function that is embedded. So here there is a big parenthesis here. So we actually want to keep this in the form that is like aligned within the same hierarchy. So make sure it is not that important in the Java, but then it is very important in Python. So make sure that you make this as a practice if you are interested in coding. Okay, so here W means the width. So here image, this function image width will measure the width of the image automatically. And then float h is the height of the image. And then the float m is something that I added as an additional kind of the float to not confuse myself, but want some separate value to, let's say, define the width, but it's not completely necessary. Completely necessary. But yeah, here we are going to do another if statement within this hierarchy. So you see how this is a inset. So once there is an inset, it means that this is a one thing, and then this is including that one thing. Okay. Here, if height is bigger than W equals H. So this is the let's say there are some images like this, right? And it's trying to, let's say, define if it's not, let's say, cutting like this, or basically overcutting. To prevent that overcutting, if you overcut, this will be completely black, and then that's not really desirable for our application. So we want to keep this in the realm of actual image like this, right? So this is to avoid that issue. And I'm just defining another factor here. Where this is the dimension of a desired dimension, and then this is the height or the width of the image. So if this is an image, there's a desirable dimension, and then how many, let's say, cuts do you want to have? And based on these, we can resize. This is just some, math. And I made this is probably not the proper way to do it, but I just made another the variable called the outName1, which will create let me explain this. Sure, right, this. So here, this is outer namespace, and then this is the underscore, and then this is the number of the image, and then this is just the the file format. What this does is that this indicates where it belongs, and then this is what's the name that you want to have, and then hyphen, and then the number of the image. So let's say if you have this image in the dataset folder, you can have let's say define namespace, for example, test, right? And then plus this, you see that this is in this definition, and whenever you do this, it becomes, let's say, it's indicating this is not included in the function itself. This is more treated as a text. So this is a number of the defined number of the images, integer image. How many images did you just created from this? That's the yeah, that's the function. And after that, we're going to save it. So your image is going to be saved as an outname 1, which is the definition, right? And once that's done, we're going to indicate that this program is finished. This draw function is finished. So this is an important practice. Even without the exit, it will run, but then it will never quit running. So it will fry your memory and all that kind of stuff. So make sure to have the exit. What this does is that stop this process and then purge your memory. Okay. So let's try this. We define this in data set, and then we want to output it in the output folder, and everything seems fine. No, okay. There's always error because I was not keeping the same name convention, and that's fine.
Can you stay at the end a little bit, just 1 second to finish code?
Yeah, no problem. Are you good now, Carlos? For some reason, it's not recognizing my file location. Are you good now, Carlos?
Yeah, I finished copying. Yeah, thank you. I am
Okay.
I am getting an error at line 14 in, you know, that one that says in there. It says not
Yeah.
a symbol U, which is Latin capital letter U.
Can you share your screen for a second?
Okay.
Okay, line 14.
So this here. I think the path it's okay. I don't know what's the problem here.
No, you need to change the backslash to the forward slash.
Oh, all of them?
Yeah.
Oh,
Do Control F.
Control F.
Yeah. And then type the backslash.
Okay.
Yeah, and then forward slash and replace all. Right.
Okay.
And another thing, you need to end it with the backslash here, right? I mean forward
Okay.
slash. Yeah.
Okay. Okay. What is this? I got an error here. Can you tell the error here? Syntax error.
So you didn't close it with the parentheses, right? At
Oh,
the end.
right, right.
Yeah. Over there. Outname one. Did you define outname one previously?
We did, right? Or didn't we?
Name
Name. Is it just out name? Is it just out name?
Yeah, no, I outname one. It should be outname one. Let's see. Outname. Split. You got that. Well, it's hard to let's say troubleshoot the for a longer time because of time limit that we're given. So
Yeah.
I mean, I'm going to share what I have as a working version with you, and then you can review like what's the difference between my version and your version.
Okay, that's great. Thank you.
Yeah. So let me share back my screen. Here, as you did, I have to change this all. And this, and okay, it didn't cut. What's the current dimension of this? Okay, that was already 520. That's why. Okay, so we can change that, right? So image size. Let's say we want to produce something like an even number of even multiple number of 512. So if you multiply 512 by 4, that's a 2048, right? So let's say you have image size like this. Yeah. Okay. And export this again to the image to cut. I replace that image with the new image. Let's go check this. Okay, yeah, you see the 2048 by 2048. Once we have that, this is the wrong code. So, it didn't cut. Why is it inaccessible? I recently changed my directories from P to G. Maybe something over there went wrong. Give me a sec. Yeah, it should be okay. I will test this on the I think I should test this on the different drive. I think there is some sort of authorization issue between the drives. Sorry about this, guys. I'll just do it in the local drive. I didn't change the. Sorry. for some reasons. But I'll double check on this. But if you see some of the things that I've cut before, you can actually like automate this like a image cutting process into this, you know, same frame, but then you cut it every few frames or something, and then you do image segmentation. You can automate the image segmentation. Like for something like this too, this is for my like object detection research, but the original image was more of a longitudinally like this, but then if you want to have it as a rectangular image, you can cut it like this. So it's supposed to work like that, but I don't know like what's wrong with the current drive setting. But you know, something's not working. I'll double check on this, and then I'll give you the working file, working the code by end of tonight, so that you can use that to produce you know, some data sets for your image stuff, so that you don't have to worry about making all this in the Photoshop one by one. So ideally, you want to have, let's say, you have this as a 2048 by 2048, and then you can, let's say, draw a line here, and then see how much of a spacing between this is. Let's say this is 256, or you know, it could be 512. Just for the, you know, sake of the conversation, then you can actually automate the cutting process with your processing. So you just need to measure what's the current width and the height of your image. This is the current width and height of your image, and then let's say this is something like 248. And then let's say this one voxel is 255 or 128 or 512, doesn't matter. But for the purposes of our you know, research, we would prefer 512. But anyway, if it's a 512, you can let's say design your data set based on your image size, right? Let's say this is not, you know, 2048, but then this is a 5096. Then you will make if you divide this by 512, you will have 8 images per one shot, right? So you get the idea how you should segment your image. Yeah, so sorry about the, you know, the code not working. I recently changed some settings in my computer, and that I think have impacted some of the compatibility issue for the access, because if you look at this the message here, it's having some problem accessing the hard drive for some reason. So I'll make sure this this works by end of tonight. But, yeah. Next step is so let's work on the some more processing tutorial that's, you know, not the image, but more of a kind of a geometry based stuff. This doesn't have to do with the it doesn't have anything to do with the hard drive issue, so this should work. So we're going to do the thing called the cellular automata. Cellular automata is something that's defined by the von Neumann. So here, this is the cellular automata. So it's the kind of the first of any sort of kind of generative the computer model or computer coding. So there is these sets of rules, and then based on these sets of rules, it automatically generates these the cells within this canvas. So we're going to try to do this, and the reason why we're doing this is that because this really demonstrates the let's say relationship from one dimensional element to another dimensional element in a very simple way, and then you can make certain rules to create certain patterns or certain geometry using the processing. So it is like the 101 of, let's say, procedural design using code. So let's go over this first, and then we can change few variables to, let's say, fit the to make different types of compositions. Okay. So here's let's make the title first. So we're doing this based on the rule the 100. So if you type on this is the rule. Okay, so it creates a division from the one big space, and then small division, smaller division, smaller division. It makes the division, so it does like a grow exponentially from the starting point to the end. And these are some of the pattern. So 0 means that it isn't there, and 1 means it is there. 1 means it is there. 0 is not there. And based on the rules, you can change like these rules to create these very various patterns. I mean, this isn't, let's say, completely related to what we're doing here, what we're doing for the workshop. But then for the later part of the workshop, we need some understanding of processing to get to the higher level of processing. So I wanted to include this as a tutorial for the processing, because later on we're going to do the feature matching for the facade assembly. So let's work on. So this is yeah. So this is the rules. You see there. This is the row of this is a row of the empty shell, and then based on, let's say, the centerpiece, it defines the condition. If everything is empty, it's a 0. If one neighbor on the right and the one neighbor on the bottom, if there's these two neighbors, then this one. And if there's only one neighbor on the south, that's the field. And then they define this by, if this is a center, they have 3 values here, like this. So it could be 1, 1, 1, it could be 1, 0, 1, and then 1, 0, 1 means that there is one neighbor here, and also one neighbor here. No, like no neighbor here, because this is 0, and then there's a neighbor here. So if you draw as a rectangle, it's like this, right? So by doing this, you are making the geometry that this cellular automata was Yeah. So if you, let's say, if you can zoom into it, do you see how like this is a processing in a 0 and 1s? That is deciding where things should be empty and then where things should be all like connected as a dots. So yeah. Let's go ahead and then do this. Now we have to define the cells first. Cell as array. So whenever, as I mentioned before, whenever there is a parenthesis here, that it means that we're making this variable as an array. And then there is cells 2, so we need for the later part we need these two definition of cells. So we're going to define these cells here as an array. And here we're going to set up our file. So notice that I'm working on Python, not Java here. So we can define our size here just for the purposes of the tutorial. I'm just going to use the size here, and then the background the 255 to 55, and because this is in array, we want to make a for loop. This is a slightly different language, so it might be a little bit confusing, but it's doing the same thing. This is a for loop. Instead of having in Java, like you define the I first, and then you define the condition for like the I. In Python, you do for I in range. For I in range means that when I is under certain circumstance, something happens. If I is outside of this certain condition, nothing happens. So that's the kind of conditional statement here that we're writing here. And equal here, equal means that when I is equal to, like mathematically equal to something. So int is integer. Append here is one function that you will use very often in Python. Append is that at the end of the book there's appendix. It's the kind of same thing. You're basically storing some value in the array here. So append one is that it's going to append. Let's say I told you the computer language starts from the 1, so it's going to store the second value into the cells. So there's an array here, and then let's say there's a this value here. So this is in terms of an array. If this is at 0 is 0. Let's say this is 1. Okay, 1 equals 1. Right? So because this is corresponding to this one, and then this is corresponding to this one, right?
Sorry for interrupting, but can I ask a quick question?
Yeah.
So what is the reason that we assign the 1 instead of the 0 over there?
So what for the cell?
Yes, right. For the cell. So we just assign the 1.
Yeah, because you see, I put it as an if statement here, right?
Mm-hmm.
And then I'm making a condition for, let's say, two different condition. Here, this is one condition, but if else, we're going to say cell is appending 0.
Gotcha.
Yeah. So we're actually dividing the condition into, so this was one thing, but then by if statement, we're dividing this condition into two different, let's say, information. So if there was a, 1, 2, 3, 4 as an array, we're saying like if I is a smaller than 3, store it to, let's say, A, right? If we say that, we're going to store value A, value 1, 2 in A, 1, 2, yes? And then for the else condition, we're going to put the 3 and 4 in, let's say, B. Like if you say like B is else, B is otherwise, yeah. And the reason why we're doing the appending to the 1 and 2 is that we had this like a cell condition, right?
Mhm.
This is the yourself, and then we're defining the surrounding condition, and then based
Understood.
on the
Got it.
yeah. Okay.
Gotcha. Awesome. Thank you.
Yeah, so we just set that up here, and then we now drawing. Now, like the purpose for the print cell is to check if the cell is registered, within the value for the cells are registers under the appendix. And now it gets a little bit complicated. Here, we're doing another I statement. So the one thing to note, so when this is used, you notice that I use I, and then here I use I again. The reason why I can do that is because this is a two different function, right? Definition, two different definition. Def something means that this is a function. So you can, whenever you need this function, you can actually call this definition so that it will do this thing for you. So for example, whenever you use like something as simple as, let's say, open a mail, it basically, this function is acting as this button, okay? And within that button, it's like a metaverse, right? It's like a word within a world. So in this world, I is new. So we can use I again. And this len function is it's representing the length of the cell. So if let's say you have an array A, and then that has a 1, 2, 3, 4, or let's say to be accurate, a 0, 1, 2, 3, 4. What's the length of this A? If you do len A, then it will, and then if let's say you do print len A, then it will outcome 1, 2, 3, 4, 5, 5. Make sense? We're doing this because we don't want to overrun the statement, right? If there's only 5 components here, you don't need to run more than 5 times. So I here is referring to that how many times are we going to run, and then that is defined by the cell number. Okay. And L is just another variable. It can be J, doesn't matter. And this is just a mathematical function to, let's say, have some 2 variables that's one step behind. And this if statement is for the L, condition L, and then we're going to make R variable, which is +1. So the reason for this is that you have yourself, right? And then this is L, this is R, okay? So we're here first defining for the I, like if I in, let's say, let me draw this again. So this cell I is referring to, we append this number here, right? We append this number, and here there is a one space and 2 space, and then the value for these numbers should be either 1 or 0. So we're defining when this was 1, when this is 1, what are the conditions? Or like more accurately here, you know, this is referring to this, right? So the first one, if there is an array 1, 2, 3, 4, we're referring to this one, and then what I'm just like saying this is 1, 2, 3, 4 because this is easier sequence, but then ideally it will be all 1, 0, 1, 0, 0, 1, things like this. So we're defining when the cell I is 1, and then here this is just a function to count the frame. So you know, it's not important for the mathematical part of this thing. Just wanted to include that. And when this is I, when this is 1, I is 1. So here this is I, R, or not R. This is L. This is L, I, R, right? So the I is yourself. When this is 1, so this is 1. But what are these numbers, right? What is this? So we're defining that right now. When L is 0, N is basically just like N. Like to satisfy this if condition, you have to satisfy this condition and the condition that comes after. Right? Something like this. That means we're defining a 0, 1, 0 condition. 0, 1, 0 condition means empty, full, empty. Then two I equals 1. So the cell 2 is referring to this one. So this is like that, right? So that is now one condition. And this needs to be inset like this because it's within that definition. Um, can anyone tell me what this is doing? So now I is still 1. That means I is a full field, right? And then L is 1. L is here. L is this. And then R is 0, which is R is empty. Cell 2 is a 0, so this is empty. So we're defining conditions, various conditions that each one of them is having. It's it's something like a TSNE, like that level of the complexity can achieve from this sort of a relationship kind of the logic. So how does one neighbor relate to another neighbor? I'm just gonna set up more conditions here. I'm thinking of all the possibilities. All the possibilities for this relationship strategy when the yourself is a field. So if I draw this everything, so this is this, and then this is this, and then this is this, and that's everything's painted. I mean, I didn't right. I guess I didn't write one line. Let me finish this. So here, this condition is that all this row is painted. Right. So these are the conditions that can happen within this, the rule set, the one that I showed you of the von Neumann, the 101 rule, this rule. Yeah.
But you always start with the one in the center. That's I, and that's 1, right? Because that's
Yeah.
all. Oh, okay.
So you notice that I only have an if condition here, and then how can we describe, let's say, when I is empty? What would be the logical thing to do? Anyone? Here, from here.
Just use else.
Yeah, exactly. Right. You see where it's going. Okay. Now, because this one condition is defined here so far, so we have to actually inset this, aligning with if here. Make sure this aligns. Unlike the Java, whenever you're ending something, you have to, for the function, you have to put the colon. And actually, I made a mistake here, and this should be colon. So this is all for the when I is a 0. Okay, so So, yeah, as I did on the top, like, you know, we're kind of doing the you know, same thing.
I wonder if it's like more efficient to have the else instead of having a new whole if condition. I don't know how the computer like does work with that. Like, does it matter to have an else?
So
Rather than like starting with a new if cells I is equal to 0 and then just write the whole.
here, like embed the else within here.
No, without having the else, like just starting a new line with a new if statement when
New statement. So the problem is that the one thing that's, I think that this should be the most efficient because here, this is a value 1, right? And then everything else, it should be 0. So we already made the subcategory within the data set. I mean, it's some sort of a big pool of thing. It's when it's 1 or 0, and then we can control within this the realm. But if we, let's say, do another if statement, then we actually have to define the condition when cells I equals or not equals 0, 1. We have to write this every time when we do if statement here. So that's why we use else instead of doing another if statement. Does that make sense?
Yeah.
Okay, let's keep going. Okay, now all the conditions are set, but this is not the end. We still have to okay, let's see if I missed anything. Okay, let's try it run. No. I think there's alignment issue here. Here, what's wrong with 928? Okay, typo. Yeah. You see, like there is like a degree of difference between the one thing to another thing, and it's kind of plotting things in terms of as a relationship aesthetics. Like there's a one thing place and another thing place, and this is just a very basic of how you set up a relationship from one variable to another variable. This is like basic of the basics. And there is a more complicated, little bit more complicated version too. This one. Instead of plotting everything at once, it's plotting things more like inside as you process. So as you can see, like there is a things are more adding on these edges. So it's like almost like a tree is growing out of something, or bacteria is growing out of something. But basically, you're using the same rule set to create this, but there are only a few differences. So if you compare these two code, the frame count is just, you know, how many times are you going to run? There are some changes in the this side. So instead of running it only on the one dimensional using I, here I added another dimensional string j. So it is not only, let's say, plotting it one direction. So how the automata, this version of automata worked was that there is this condition here, and then they kind of spread out as they process. So that's why you saw this as a more of a triangle, whereas this one, if you run it, there is something happening once, let's say, and then within this boundary, there's another thing happening at the same time on the new data sets or the new data array that's created. So it's like a kind of almost like a fractal growth. You know how broccoli is like a growing in fractal? There's like a small broccoli within the larger broccoli, and then those broccoli makes the broccoli. So that's sort of a thing. So if I run this again, here, yeah, you can see it's it's like adding more stuff as the sequence goes by. Yeah, so now we're going to try to make this based on the what we had before, to realize what are the differences that, or what kind of consideration that you need to make for the two-dimensional the data strings instead of one. So here, let's do this. So I'm going to save this first as a and then save another file with the 2D, so that we don't lose what we had before. So the basic setup in the beginning is the same, but then here we have to add something. We were working as a column, like I mean, not literally like column as an object, but then in terms of a data structure, because it was a one-dimensional. This is I, and then it goes a sequence, like this is a frame count. And for this one, we want another dimension here, which is this to this direction. This is J. So that's why we're calling this as a row instead of having just as a column. If you just add another variable here, that's not two-dimensional, right? It's just a separate variable. So we need to make this as a row. Okay, so row is empty array right now, and then for this, we're going to make another variable j, and this is for the height of the our set size height. And, here we have to define the relationship between the I and J. So here I this definition is making this, the divisions. So that's why we're having this line here. So here, instead of having that the whole as over the cell, you see this like a cells append, cells to append. We are now adding another dimension, so which is the row append. And as we do the in the on this line, we're going to do another else statement here, which is row append 2. And for this one, this needs to also change a little bit, because this was a one-dimensional information array, and then now this is a two-dimensional. So I'm just going to comment this out. The shortcut for that is that the control /. So once this is once it's commented, it's not included in your the function. It's just a text information. So whenever you don't want to use certain part of your code, you can just simply comment it out. Since this row it already has information for both I and J in relationship to the our size. So we're just going to use the row as a appendix tool. So that's instead of this line, we're only using this because if and else is already predefined in the row. So we're using the row as a kind of anchoring information to create the appendix for the cells and cells 2. So now we don't need this. So we're going to just delete this for the, or do you guys just want me to keep it here so that you know that what I changed? I guess it doesn't matter. And here, print cells. This is for the purposes of how you see the the information that's printed here. So you can still keep this. And for the this frame counting, we don't want actually to run this infinitely, because this is a little bit more heavier than what we had as a one-dimensional array thing. So we would want to actually limit this frame count to a certain number. But it's up to you that what the number, what the number should be. But for mine, I'm just going to use this. I don't know, 30 maybe, yeah, 30. And here, since we have both I and J, we have to consider double loop. So what I mean by double loop is that whenever I is changing, you have to define what J is too. So we're going to for loop I first, but then for loop J is embedded in the I. So in terms of a table, so let's say this is I, this is J. Whenever this is changing, we want to know the relative, the information over J too, right? Because this, let's say this is a 0, 0, this is 1, 1. There could be like various information that is embedded within this grid. So if you're changing this number, you have to know what J is too. I in range. It's the same as this one, but we're going to use J as well. But in relationship to the I. So do you see how I link the cell I in the J? So the J is defined by the length of the cells in terms of a column. So the row is defined by the length of the column. Okay. Zero, that means the starting point, right? And since we already use I and J for our operation, we should use something else. For example, like X. And Y. X is not equal to, or Y is not equal to 0. X1 is equal to I plus X. And this is basically, we're setting up very similar condition to this condition. And now I'm going to introduce another function, which is else if. Else if is, it stands for else if, okay? So else if is let's say it's like a something something in between the else and if, I guess. It's conceptually, I guess, a little hard to explain. And this is for the X condition, and then we're defining now for the Y condition. This plus equal 1 is basically same function as a plus plus. Like, so you remember in Java when you did I++, it became like this equation. So it's the same for here too. Whenever your the counting your count or iteration. So this is iteration, okay? So first iteration is this, and the second iteration is this, let's say, and then the this line is referring to, let's say, on count 1, and then the this iteration is referring to the on count 0. So this is this, but then remember, this is increasing every time you're adding. You're adding from 1 to 2, or 1 plus 1, and then 2 plus 1, 3 plus 1. So this sort of the mathematical relationship. So look at this. How far should that go? This should be aligning with the, I think, this one. Yes. If you're not sure, 1, 2, 3. Cells I J. So if this was defining the movement over your iteration in the 2D space, or this chunk, now this line from this line, it is defining the relationship between the one element to another element, like your neighbors. Zero and 0. And this is basically all the same. More, it's not same, but like these two definition was replacing these. You see, like in the one-dimensional condition, it was a much clear where when you only have to think about the one-dimensional kind of relationship from one to another. So the dimension, this is dimensional changes, right? Whenever there is a dimensional change, you have to think about the, let's say, more complex relationship between one to another, right? So this, as a result, you have to introduce a lot more variables here. And for example, x and y for their ranges, and you have to consider I in relationship to j, and the j in relationship to the I. So so that it creates it operates in the same rule set, but then in more of a higher dimensional space. We have to write this one's again too, because this is only reflecting the one-dimensional array. We can reuse some of this, since it only has a consideration for the I, we are adding consideration for the J. Same as how we did it on the top here. And adding if statement here. We're defining the coordinates. J. I'm just gonna, for the sake of cleanness, I'm just going to delete this. You already have the previous version anyway, so what did I do wrong? Else if that is one on top one. Cell is not defined, so cells, okay. Look at that. But here, because we didn't define the background, it looks slightly different. So I think what I'm going to do here is the define the background. Yeah, okay, there you go. Yeah. Okay, so this other automata, these both files are working. So I'm going to share that in the chat, and just in case if you guys couldn't make it work. Okay, that's uploaded. We'll take a short break and then come back, and then we will look at some of the examples for the TSNE through the Google Colab, and based on what we saw today or what we learned basics about the TSNE, we will write our own Python code for the TSNE, and also through that we learn how to use Google Colab so that you don't have to have a super powerful graphics card to run some machine learning and AI stuff. Okay. But for those of you who already installed the Anaconda and the Style 10 and the TensorFlow, you can follow the exact same method that I'm doing in the tutorial for tomorrow with the command window. Okay. So we'll come back at 6:35. Is that okay, guys?
Sounds good.
Okay, yeah. See you guys.
Actually, can I ask a quick question?
Yeah.
Okay, so do I need to install some other plugin to see that kind of graphics visually?
Yes, yes. Let's go over that. So here on the tool, add tool.
Okay.
Yeah, and go to the library, and then search for the PZChem.
PEIS. Okay.
PZChem, and then select it here, and then click install.
Is it Jonathan? Okay, just install. Okay.
Yeah.
All right. Then.
Yeah. And I would recommend installing toxic libraries, which is here, as you can see on the screen, toxic ellipse. So this is a very useful library for a lot of the functions that you use very often in processing.
Okay.
Just in general, you know, and what else do I have? Also, you can export your OBJ into processing if you want to. So that's you know, another useful thing. But other than that, it's fine.
OBJ?
OBJ export. Yeah, OBJ export.
Oh, got it. Okay, I just found it.
Okay, cool.